I mean, that's just ridiculous. The figure says IQR, Dave says it's not the IQR. So now that makes the actual middle 50% of the data include only plaque progression. And how does he defend it? All the dots are there, he says. Well, I guess it does not matter that the summary statistic labeled the IQR is not actually the IQR, because you can just stare at a cloud of individual data points randomly spread left and right and figure it out for yourself. I mean, why even have an IQR or even a median at all then? And somehow, after all of that, conceding essentially all the factual criticism, Dave rates this as negligible.
The difference is negligible.
So the criticism was right, but apparently it just doesn't matter. This might become a theme. And hey, what about the revascularization event? Okay, for anyone who needs context, this all started with the Keto CTA study, and we put out a video raising some problems with their preprint, mostly statistical problems. And Dave Feldman, an author of the study, founder and president of the Citizen Science Foundation, which funded the study, and writer and star of the recent Cholesterol Code documentary, and friend of the show, recently published a lengthy response to the statistical problems I raised in our video critiquing the Keto CTA preprint, the landmark research study behind that documentary. So I highly recommend watching that previous video before this one and then reading Dave's article responding to those criticisms. This video has 4 main parts. In part 1, I'll go over Dave's risk matrix, and in part 2, I'll review Dave's responses to each of the problems. And in part 3, I'll discuss the broader context of the problems. And finally, in part 4, I'll gradually lose my mind trying to read the AI slop in Dave's article. Okay, so let's first talk about how Dave scored the problems. Dave organizes his response around a risk matrix that he designed and he scored himself, mostly asking whether each problem corrected in isolation would change the conclusion he considers important. Sometimes it's not clear exactly what conclusion he's referring to, but he just says the conclusion. And the matrix just asks 2 questions. Did the problem change the reader's understanding? And does the finding or conclusion shift once the error is corrected? Said a bit more precisely, does Dave think correcting the error would change the reader's understanding? And does Dave think that correcting the error would change his preferred conclusion? And the response pattern is generally something like, define the error very narrowly, judge it in isolation, grade it subjectively, with anything less than overturning the result graded as a minor problem. But other than the obvious subjectivity of the scoring, Dave's matrix, of course, misses many important things. It does not account for accumulation, interaction, or direction of the problems. These are not isolated problems in separate studies. And how much confidence should we place in the conclusions once these problems have been considered together? And very importantly, what about the larger context? When a non-peer-reviewed study, a provisional preprint, is being used to reassure people about potentially serious health risks, any errors, omissions, and weak analyses cannot be just dismissed because the preferred conclusion appears to survive in isolation. And context makes another of Dave's defenses really weak. Dave says, preprints are expected to have rough edges, and that's part of the point. Come on, this is not some preliminary first pass at an unfamiliar data set. They already published results from the same cohort, and that paper had some really rough edges. Rough edges. Anyway, this is just an analysis of the same participants, only using different plaque measurements with straightforward statistical modeling. There's, of course, more I could say about this matrix and his general defense, but at some point, arguing over Dave's scoring system is just a distraction from the actual statistical problems. So let's look at how he actually responds to the 6 problems themselves. Problem 1, the misdefined exposure variable. Okay, so Dave concedes that LDL exposure is not actually LDL exposure. It is actually LDL at follow-up. But then he argues that the authors tried several other LDL measures and obtained similar results. Okay, but I'll state again, the reported variable was not LDL-C exposure, and calling it exposure made a single measurement sound like cumulative LDL-C burden. And that label greatly strengthened the interpretation of what was actually tested. And why was this misdefinition the one they chose to write in the paper? How did it actually happen in the first place? But anyway, it's a minor problem. Okay, problem 2, fabricated IQR metric. Now, Dave's response starts by establishing that the IQR divided by 2 actually has a name. The half width he's describing, half the IQR, is the semi-interquartile range, also called the quartile deviation, a standard named statistic. Standard is doing a lot of work there. Okay, Dave, but that is not the problem I was pointing to. The problem wasn't dividing IQR by 2, it's what they did with it. They took the IQR, divided it by 2, and used it as an equal distance above and below the median, even though the actual Q1 to Q3 interval was not symmetric around the median. That shifted the entire display interval downward and just happened to make the summary of plaque progression look more reassuring. That interval they constructed is not the IQR. Its endpoints are not Q1 and Q3, and it does not represent the middle 50% of the data. Separately, perhaps I was a little too categorical in the original video when I said that this full median plus or minus half the IQR interval did not exist and described that calculation as fabricated. So I will retract the absolute claim that the interval never exists. But this is pretty much just a misdirection. That is not the standard display. And don't take my word for it. Look at the guidance. Q1 to Q3. I could not find a single guideline recommending median plus or minus the SIQR in order to show the IQR, or for any other reason. Dave says it's just a labeling error. Well, let's look at how well that labeling error characterization holds up. Here's how it was reported in the 2025 JAC paper with the caption, "The shaded area represents the IQR, 9.3 to 47. But that shaded area is not the IQR. It is median plus or minus the SIQR for baseline and 1-year follow-up." Also, more strangely, when they were having some issues with them not reporting the primary outcome, the statistician tweeted one of those charts and he said, "I have to disagree. We did. It's highlighted by size, color, and within confidence bands. But those are not confidence bands. Confidence bands have a specific statistical meaning. So it's interesting he did not call the bands the IQR. And here's what was reported in the preprint. The red dot illustrates the respective median annual change and its whiskers, its interquartile range. And in the text, it states data are presented using the median with 25th to 75th percentiles. And for some reason, there's a table 1, that shows Q1 and Q3 for most of the baseline values. But for the plaque change values, we only are presented with the IQR as a single value. That is a choice, a strange choice. And just to illustrate how ridiculous this median plus or minus SIQR is, I've created these 3 charts. The data is synthetic. It just shows 3 distributions. All 3 of these charts have the exact same median, the exact same IQR, and then of course the exact same SIQR. However, each one has very different Q1 to Q3 range. And you can see these distributions are very different. There's one that's symmetric. There's one that's right skewed, like the plaque progression data. There's one that's left skewed. And you can see the blue dot with the whiskers shows at the actual Q1 to Q3, and the red dot with the whiskers shows the median plus or minus SIQR. And you can see this constructed synthetic interval is ridiculous. It doesn't give us any information. We don't know anything about the distribution. And furthermore, in the right skewed distribution, note that the bottom of the median plus or minus SIQR versus the Q1 value, it shifts from negative to a positive, just like in Dave's correction of the actual value. And he says our lower whisker sits at about negative 2.2, while the 25th percentile is about positive 1. A reader who takes IQR at face value would put a quarter of the cohort below negative 2.2, and that isn't where the data sit. And later, either way, the finding doesn't move because we plot every individual point. The real distribution is visible regardless of the whisker. Okay, that is not a negligible cosmetic difference. The interval labeled the IQR extends down to about negative 2.2 into plaque regression. But the actual first quartile is positive 1. So the true middle 50% of the cohort lies entirely on the plaque progression side of 0. In other words, their constructed interval made the middle 50% of the distribution appear to include plaque regression, when it does not actually. And the distortion looks even worse for the PAV chart. The actual Q1 would also flip from negative to positive, and it appears that the actual Q3 value is between about 0.8 to 0.9%, just under the 1% rapid progression threshold. That's interesting. And showing every individual point does not make all of this okay. If readers are supposed to figure out the quartiles themselves from a cloud of points randomly spread left and right, then why provide values for the median, much less Q1 to Q3 at all? The purpose of the summary interval is to summarize the distribution accurately and clearly, and their interval does not. It distorts. It misleads. And I still cannot think of a reasonable reason why anyone would go against convention and guidelines and plot median plus or minus SIQR here. Can you? And an adequate response should explain why that interval was chosen in the first place and how it came to be labeled as the IQR. In 2 papers, not just rename it and state that the conclusion doesn't change. Because I'd say the conclusion does change. So directly to the statistician, you reported Q1 to Q3 for the baseline data, but in 2 papers, the figure captions described these whiskers or bands as the IQR, but what was actually plotted was median plus or minus SIQR. We know that's true. Dave concedes that. Okay, and this is a direct question to the statistician who really needs to answer this. Why did you choose to plot median plus or minus SIQR for these right-skewed distributions instead of the conventional Q1 to Q3 interval? But I guess it's just an isolated labeling error, so apparently it barely matters. Okay, on to problem 3, missing results and explanations. So yes, the ApoB model is missing. Dave concedes that, but there is another part of this criticism that Dave just does not answer at all. He totally ignores it. As I said in that original criticism, one participant had a revascularization event during the study. So a revascularization event means a procedure to restore blood flow to the heart, like a stent or even a bypass surgery. Was the revascularized patient included in the modeling or not? And look, I'm not trying to make light of this. I hope the participant is doing okay, but from a statistical reporting standpoint, we still need to know how this event was handled in the data analysis and why the sample sizes differ. Those are basic data handling questions that should be reported in a study, and Dave's response completely ignores them. Okay, problem 4, the incoherent equivalence testing, or the incoherent TOST procedure. So Dave says that the technical questions about the TOST procedure belong in the statistician's response. Of course they do, but don't all of these criticisms belong there? Dave responds and grades criticisms that are overwhelmingly statistical. And why is Dave grading criticisms on the statistician's work? So Dave doesn't have all the information, but he still grades this problem and tells us how severe it is and if it matters. And he answers the TOST criticism by, again, asking whether TOST changes the paper's conclusion. Dave minimizes the TOST analysis by just calling it a backstop included to further support the result. And that is exactly why grading it in isolation is misleading. A backstop, or literally further support, is part of the cumulative statistical case. If it is unjustified or cannot be verified, the paper loses one of the analyses used to make the no association findings appear more robust. But that doesn't matter in Dave's risk matrix. And even more concerning, the result of TOST is reported in the text as a single confidence interval of 0.00 to 0.00 without identifying which model it belongs to. Is it the LDLC model? Is it the ApoB model? Is it the Days on Keto diet model? I asked this in the video, but he did not respond, and we still don't know. And as I said, that confidence interval appears mathematically incompatible with either the LDLC or the ApoB model. Is this misleading reporting or just a labeling error? Apparently, that's for the statistician to tell us, but it still gets graded by Dave. Problem 5 is the reassuring power analysis. And Dave agrees again. The post-hoc power calculation cannot turn a null result into evidence of no association. But then he says removing it changes only the wording. And again, that misses the point. The whole purpose of the power calculation was to reassure readers that the null association was not due to low power. In other words, to strengthen the interpretation of the result. Dave then points to near zero estimates on both imaging platforms, saying those results have nothing to do with the power calculation. But the two imaging platforms definitely don't make power irrelevant. These are two measurement pipelines applied to exactly the same underlying study data. The same cohort, the same participants, the same lipid measurements, the same one-year follow-up, the same underlying scans, same selection process, and the same basic design limitations. In fact, the different platforms do not appear to confirm the individual one-year plaque change especially well. The heart flow distribution shows much greater dispersion, the shape of the distributions look different, and the platforms disagree substantially on who actually regressed. So running the same scans through a second AI algorithm does not add participants, it does not extend follow-up or improve the exposure contrast or fix the design problems. Both platforms could produce near zero estimates for the same underlying reason, and that doesn't necessarily have to be because there's actually no association. That is not independent evidence about the LDL plaque association. It is just confirmation that two algorithms applied to the same scans give similar answers. And these are very different things than an independent confirmation. They both could just be too noisy to detect anything. And also in this response, Dave states that Bayes factors have nothing to do with the power calculation, but the preprint itself explicitly used Bayes factors to reassure readers that the null association was not due to low power. And that's a bit strange to say when Dave has just said that Bayes factors have nothing to do with power. But okay, remove the power argument and the evidence becomes less reassuring. The estimate is unchanged, but the claimed strength of the evidence is not. Anyway, apparently the strength of evidence is just wording. Problem 6, a signal weakening pipeline built on fragile models. This one, in the summary video, I might not have explained the point as clearly as I could have. Let's do that now. So Dave says that simply identifying design limitations is not enough. According to him, I need to show that these limitations push the association towards zero. That's the LDL or ApoB to plaque progression association, and pushed it hard enough to erase an effect of the size the prior literature predicts. Probably in isolation too. But the effect of the size the prior literature predicts is doing an enormous amount of work there. So the effect size that he's talking about comes directly from the preprint. So what do the cited studies actually show? They're aggregate treatment arm averages from lipid-lowering trials and not individual level LDL versus plaque progression. And the other one is patients with established coronary artery disease and treatment-induced LDL change versus plaque change. So neither one clearly establishes the expected individual level 1 year correlation in keto CTA study. So I think saying the prior literature predicts a correlation of 0.4 to 0.6 is much stronger than those citations can justify. And he also talks about the sample size, and being told the sample is small is not the same as being shown it was too small for the effect anyone claims is there. Anyone? Like I showed, if the true observable correlation were 0.2, this study would be substantially underpowered to detect it. And more fundamentally, Dave has the burden backwards. A null result is only reassuring if the study can distinguish a negligible association from a meaningful one. And with all the noise here, I don't think the study can demonstrate that. So back to the claim that the study, design, or feature has to be shown to push the association towards zero claim. Here are a few ways those limitations could make the relationship between plaque progression and LDL-C or ApoB more difficult to detect. So take the obvious one, the time frame and the outcome itself. The effect of LDL-C and ApoB depend on cumulative exposure over years and even up to decades. But this study asks whether lipid levels predict plaque change over just 1 year. And that change is calculated by subtracting two complex imaging measurements, so measurement error from both scans gets built into that change score. A noisy 1 year change score can make a smaller signal much more difficult to distinguish reliably from the noise in the data. And this limitation does not exist in isolation. It's being analyzed in a highly selected cohort, another design issue. So Dave states that social media recruitment produces an unusual sample, and ours is unusual, but it's unusual in the exposure we selected on, not in the outcome we measured. That is just not an accurate description of the study design. The study didn't only select for LDL-C or even only the lipid triad, as Dave implies and clearly states. It's selected for a highly motivated, health-conscious group of longer-term ketogenic dieters with a very favorable metabolic and clinical profile that I'd argue is possibly one of the healthiest subgroups of people who fit this LMHR phenotype. So Dave's claim that the cohort was unusual in the exposure substantially understates how selected this population was. And that matters for the regression modeling. If you select people with very high LDL-C who also have an unusually favorable metabolic profile and no diagnosed atherosclerotic heart disease, you may select people who have remained relatively healthy despite that exposure. So that does not just isolate LDL-C. It changes the population in which the LDL-C to plaque relationship is being estimated. So within that highly selected group, the relationship between LDL-C and 1-year plaque progression could be weakened. And that would be a consequence of who made it into the study and not evidence that the LMHR phenotype neutralizes the effect of high LDL-C in some way. Now, can I say how much this might have reduced the correlation? Of course not. I am only identifying a plausible and well-understood reason why this design may be poorly equipped to reveal the broader relationship, a reason why these models should not be described as incredibly robust. But then Dave points to the reported LDL-C range of 49 to 591 milligrams per deciliter, saying that it isn't restricted to just the high end. And again, there's a lot more to this story. So the preprint states that the median was 237 and Q1 to Q3 was 202 to 308. Hey, look, it's an asymmetric distribution reported with Q1 and Q3. Huh, interesting. Okay, but let's look at the actual baseline LDL-C data that Dave posted on his blog. Only about 5 participants are below roughly 150 milligrams per deciliter. One observation at 49 and one at almost 600 makes the minimum to maximum range look enormous. And it is. So of course the range is wide, but the vast majority of the participants are still concentrated at very high LDL-C levels. So there's no conventional lower LDL-C comparison group. Wait a second. This is a study on LMHRs and near LMHRs. And by their own definition, an LMHR has an LDL-C of at least 200 milligrams per deciliter. And even the looser study inclusion criteria required at least 190. But at baseline, several participants are nowhere near that, including values around 150, 130, and of course, even 49. Now, they may have qualified based on an earlier LDL-C measurement, fine, but then what exactly does more than 5 years of sustained high LDL-C mean here? The results say all 100 participants with elevated LDL-C, and the title of the preprint is The Impact of Sustained LDL-C Elevation. That's interesting. Why are these people even in this study? 49 is really low. Why is this person who is not even close to an LMHR in the study? I thought these LDL-C values were supposed to be pretty stable in this population because they didn't change their diet. There's always something. Okay, there's one more thing here. Did anyone catch N equals 97 participants with baseline LDL-C data? Why are there only 97 participants with baseline LDL-C? All of the tables say N equals 100. So what's going on? And another important point here is that in simple linear regression, which they have used, we cannot have missing data. So if baseline LDL-C is missing for 3 people, they would either have to be excluded from the modeling or those values have to be imputed somehow. Then you could ask, if we have missing baseline LDL-C data, is there other missing data? What about follow-up LDL-C? What about ApoB? The paper just doesn't tell us. So now we don't even know the exact sample size behind each lipid model or how the missing data were handled. I mean, this is basic statistical methods reporting, and they just ignore it. There's always something more. Anyway, back to the responses. I'll quickly talk about the univariable modeling. So I should state, obviously, there's nothing inherently wrong with univariable exploratory regression models. That isn't the problem. The problem is that these simple exploratory association models were being used to claim something much stronger, that LDL-C and ApoB were not predictive of plaque progression, and that the effects were clinically negligible. Okay, I think you get the point. That whole section of the article was pretty much what I expected it would be, just downplaying the problems and having some explanation that didn't really make sense in many parts. But the part about my asymmetric standards and the nature CT comparison, well, that was a different thing entirely. So let's talk about that. Have John's standards been consistent? Now, here the article moves into something quite different. It goes from evaluating and responding to those problems I identified to evaluating myself and basically my credibility as a critic. Pretty much goes off the rails into absurdity and ridiculousness. And it starts with setting up the comparison with Nature CT. John selected a new study as a reference group to argue our study looks worse by comparison, and he chose one, Nature CT. John choosing this specific study matters. Whatever first put the comparison in the air, he's the one who selected this study and vouched for it. It was Dave himself comparing the studies on X, which I said in the podcast, but he didn't mention. The best we got for now, I think. I did say that. Sorry, before we start, I do want to say that it's not a perfect comparison. They're, of course, slightly different. It's a different time period, slightly different methods. So I wouldn't take it as like a one-to-one perfect comparison, but it's the best we got for now, I think. Yep, I really was vouching for the study there. I mean, come on. And I was using Nature CT's reported plaque progression results descriptively. I did not present Nature CT as some methodologically superior study to Keto CTA, and I didn't endorse all of its analyses or hold it up as a benchmark of study quality. It was just an interesting comparison. And what really bothers me about this section is how much Dave stretches what I actually said to fit the conclusion he wants you to believe. Like a qualified statement about Nature CT as the best available comparison group becomes me vouching for the study. A descriptive comparator becomes a methodological benchmark, and a statement of baseline differences that are reported descriptively becomes causal flavored. And he takes criticisms I made about the modeling and the specific analyses in Keto CTA study and turns them into some generic checklist and emphasizes whatever problems he can find in Nature CT. And then he asks why I did not apply that checklist identically to Nature CT. At every step, he chooses the interpretation that makes my argument and me as a critic look as inconsistent as possible. And once you look at the actual items in the checklist, the supposed inconsistency just becomes absurd. There's adjustment and modeling, and Nature CT is a descriptive paper, so it of course didn't need a regression model. But he says my descriptive comparison did, okay? I compared what happened and not why. It was not causal. And the code, I asked for Keto CTA's code because I found significant statistical problems and I wanted to investigate. Although I generally am for papers published in code, I think that's. And for the model diagnostics, Keto CTA study made strong claims from the regression models and explicitly said that all linear model assumptions were corroborated. But they weren't. I showed they weren't. He applies that to Nature CT, which was a descriptive study, of course. And in Nature CT, the most they did was some paired t-test on plaque change. Pretending those deserve identical scrutiny is absurd. And the confidence interval, the lack of the confidence interval in Nature CT on the 6 of 205 rapid progressors. I mean, okay, it might be useful, but I think it's not as clear as he probably thinks. And that is not remotely equivalent to omitting confidence intervals from models being used to argue that the effect of LDLC is null or negligible, which is the main conclusion of your paper. And that's the problem. These methodological standards, of course, should be consistent, but they have to be appropriate for the statistical methods being used, the question being asked, and the conclusions being drawn in the study. And anyway, all of this is just a distraction from the statistical problems in Keto CTA preprint. If you believe that I'm an inconsistent critic, you're going to see the problems I identified as overblown, selective, or not worth taking seriously. But the fact that Dave chose to go after my credibility as a critic, I think says a lot more about the strength of his responses to those problems than it does about me. None of that changes whether the statistical problems I identified are actually problems, and important problems. Those criticisms should be judged on their own merits, and that's the standard that matters. Here on screen is a list of most of the problems from both of the studies. Each study has some specific problems, but many of them are actually present in both. Okay, now Dave would have us evaluate all those issues one at a time in isolation and ask whether fixing that one specific issue would change the result. But that's not how I would evaluate the reliability of the statistical case. I think these problems indicate a pattern. They do not occur in isolation. They occur in, well, 2 papers by the same research group, and the analyses all work together. They all appear to support the reassurance that high LDL doesn't matter on ketogenic diets and that the no association finding is robust. This brings me to an important question that's sorely missing from Dave's matrix. What if they're wrong? What if all these null associations do not actually establish that LDL-C and ApoB are clinically negligible predictors of plaque progression in this population, or in LMHRs in general? Especially because this provisional preprint is not some obscure, highly niche study that nobody's going to read. It's presented as the landmark research study behind the Cholesterol Code documentary, a public-facing documentary that reassures people that extremely high LDL-C and ApoB on a ketogenic diet is not a problem, at the same time as advancing a much broader argument that the conventional concern about LDL-C and cardiovascular risk is overstated. And even in this highly selected cohort, a substantial population were classified as rapid plaque progressors. But you don't see that reported in the documentary or in the preprint's abstract. When a 1-year study of roughly 100 people fails to detect an association between LDL-C or ApoB and noisy plaque change, the appropriate conclusion is caution, not to build a public-facing documentary around those results and use them to reassure people about very high LDL-C and ApoB. People make real decisions based on that reassurance. And what if they're wrong? This is definitely not a respectful response. Well, the first part was decent, but it's respectful, but let's question the integrity of the critic. That's very respectful. Thank you. He chose as a benchmark. I mean, I think Dave just is annoyed that anybody's comparing Nature CT to his study because it shows that Nature CT has much fewer rapid plaque progressors. I think that's what he's really annoyed at. The catch is timing. If the critique arrives months after posting, in this case, John's is arriving 6 months later. All right, so he's going to try and thread the needle of responding to what degree I can, which means grading the responses. Okay, AI has changed everything, including how we review papers. It's AI's fault. It's not the paper's fault. Just try to understand what is being said in this paragraph. I'll read it out loud. One note on how to read the first axis, probability of impact. What is key to keep in mind is, what would a reader have to believe for this error to change their conclusion? And does the paper lead them there? A reader raising it is real evidence, M-. It sits where people look and registers when they get there. Silence proves less. It can mean nobody looked or that nobody caught it, and those point opposite ways. So a low score has to rest on something structural that keeps the error from reaching the conclusion. Is he always talking about the main conclusion of the paper, or is it the conclusion of the specific analysis? Whatever he wants, I guess. I don't know. I like this quote. Many of these minor issues were once quietly spotted by a few, but then ignored as harmless Easter eggs. I guess misdefining your central variable is just an Easter egg. I want to steelman John's positions, but then I want to question his integrity. All right. So I think that's where he's setting up the real argument, that I just am not being consistent. So just a bit of advice for anyone who's making distribution charts. This style of chart to show a distribution is not the best. The x-axis is meaningless. It's just randomly spaced from left to right, the data points, and it makes it really hard to see the shape of the distribution. You glance at it first and you're like, why is this one to the top right? Is this a scatter plot? Does the x-axis mean anything? No, it doesn't. It is meaningless. So it's really hard to see what the shape of the distribution would be. I mean, you can include this on like a box plot, but it's just, which would also show the, by default, would show the actual Q1 and Q3 interval. But this way it's just, anyway, that's not the IQR. I love the really big orange arrows here. This one. Okay, so that one, like,
here, like, I guess that's not a regressor. I mean, that one is like negative 0.0, what was it, 0.2? What is he doing? Is this a joke? I mean, it kind of is, but like, is it worth making a big deal about? Well, he seems to be making a big deal about it. Also, I think this is your fault, Calvin, because no, actually, I said to put it a little bit below. Yeah, I knew that would annoy him. All right, Dave's matrix, Dave's two-dimensional world. So Dave says this is a great way to size up how big or small a problem is. No, it's a great way to size up how big or small you think the problem is. There are two separate claims here. So these are the little things he does, like, okay, there's one little thing that he can like poke at to say, okay, this person, don't trust this person. There weren't two claims. There was one claim that this is the wrong metric. Like, come on. It's a good misdirection. That was good. SIQR, in 15 years, nobody's ever asked me to calculate that, and I've never seen it. And also it gives you absolutely no more information than just reporting the IQR range. It's just that divided by 2. So why? Maybe it's why nobody does it anymore. Where's the revascularization event? Why isn't he talking about it? I think his next thing for content is to claim that Q angio and heart flow independently confirm that there's a null association. I mean, it's the same study. Who knows if the algorithms are similar or not? It's not independent confirmation. And why did it take them so long to figure this out? It's literally like a couple lines of code. I like the move of just ignoring this one, problem 6. Just don't grade it. Here's where 5 of the 6 land, scored the same way. The same way, okay. The same subjective way. Problem 6 is the exception. I've included John's own yellow band error as the asterisk, so the grid isn't only scoring other people's mistakes. Is he implying that that makes it more valid? Clearly. Highly recommend reading each of these tables. Very good AI table making. The captions at the bottoms are very interesting. I especially like in this one that in the major arguments, for some reason, states in every row, Nature CT, not yet published, Nature CT, not yet published, Nature TT, not yet published, Nature CT introduced as the comparison, and then Nature CT not mentioned. Like, thank you for making that clear. The methodology is less complex. I mean, it's not like KISO CTA is complex, but like Nature is just descriptive and doesn't claim any like association models or anything. So that's why I wouldn't say better, it's just more straightforward. These captions are so small. The point isn't a verdict on Nature CT or its authors, it's whether John's specific category, as he's named it, major problem, is being evenly applied. Sources: 6 major problems and the age sex line dash John's video, the science behind the cholesterol code, and it got worse. I don't see any major problems with it. His linked YouTube comment. Retrospective design limits control of confounding. Take just one of those 6. Adjust for age and sex. His words on ours. The models do not even adjust for basic confounders like age and sex. Dash. Filed as one of the 6. Major problem. The comparison he built on Nature CT to argue keto shows much greater plaque progression. He compares cohorts differing in scan interval and referral, adjusting for neither. Scan interval? I mean, they annualized the data. Nature adjusts for scan interval, and Nature CT's own limitations concede its retrospective design limits control of confounding. Oh, that was not a causal statement. Please don't take that as a causal statement. It might have been causal flavored. I want to highlight this spot right here where Dave says that I found the confounder myself. Well, it's basically that Nature CT required everybody to have a CAC score of under 100. But in Keto CTA, not everybody has a CAC score of under 100. Most people do. I think it was 80 something. But I don't have the individual data, so I don't know exactly who, so I had to estimate that. Dave, why don't you tell us? You have the data. Why don't you tell us exactly how many
people in keto CTA with CAC under 100 have rapid plaque progression. That would be nice. Do John's standards travel? These AI tables, they're so bad. They're just bad. But the best part about it is the big red blocks with the X in the middle. Did John apply it here? X. Not in the video. Not raised, not raised, not raised, not raised. This is the best one. This is about the make the raw data available, no data available statement, no repository link. I say about keto CTA, I hope they'll release the full data set at a future point. Why is the X here? It says not raised. He published his own reanalysis code specifically to contrast with us. I mean, like, and if I hadn't have published my reanalysis code, what would they have said? I mean, come on. Make the analysis code available because there were major problems. His words, release the code used to analyze the data so that the results are reproducible. Sounds reasonable. Big X. Red. Hey, in fairness, caption, John did acknowledge some of Nature CT's errors, the 0.16% versus 16% slip, but only in a reply to the comment under the video, not in the video analysis itself. Now that's bolded, so that's important. Not in the video analysis itself. And he called them much smaller. It was much smaller, while calling the preprint a complete shambles. I mean, it's strong. I agree, that was strong language. But I do think the statistical case is a complete shambles. Inside the video, John did glance at Nature CT's reporting, mildly questioning the missing means. I'm not sure why they didn't just report it. I would have liked that. I would have liked them to report the means. That would have been nice. And crediting its conventional IQR reporting, I mean, only in comparison to the keto CTA reporting unconventional IQR, like almost every single other study. But he raised but he raised none of the specific errors or standards below on it. Okay. To be clear, how much is in this caption? To be clear, this checklist is speaking to John's standards as he's asserted them himself. That's in bold, that's important. Which are very quantifiable. Quantifiable, but you graded them subjectively. Anyway, not our opinion of Nature CT. So my standards applied to Nature CT are not their opinion of Nature CT. Okay, fine. This exercise is only whether that bar is applied evenly, not a verdict on its authors. His modeling standards, adjustment, comparable measurement, causal restraint, apply to the comparison he built on Nature CT, discussed in the companion text. The sources of the previous tables 1 and 2. Okay, near the end, Dave says, I'm not asking for a gentler bar. I will just create one from a matrix I graded myself. Like, I can't believe there's no mention about any broader consequences. But that's what happens when you make a matrix and you only have a two-dimensional world, I guess. And I like that the positive note that he ends on still has to criticize me as a critic first. But then thank you for the time and care I spent on the critique. Like, one thing I guess I maybe should have emphasized, why won't they report any confidence intervals on the models? I mentioned that a few times, but I mean, do they not understand null inference? Like, confidence intervals are so important if you're claiming that a null inference actually means something. Like, the first thing you do is report the confidence intervals. Okay, this is just a Google Trends for semi-interquartile range, and the interquartile range looks like it's big in Belize, the semi-interquartile range, and Nigeria. That's interesting. Okay, so let's look at the SIQR versus the IQR. Well, we got some hits in Trinidad and Tobago. Nice place. Not sure about their statistics. Now we look at some book. Okay, this is SIQR versus IQR in the book's Ngram viewer. All right, I'm done. I hope this keto CTA stuff is over for some time. It's getting ridiculous. It's making me go crazy.